Allen keys. There's many sets that I have here. I also have this set of Allen keys that I use for the bigger stuff. Comes in handy. Um, as you can see, I tried with these Allen keys the first time, didn't work. So I simply went to the other set of Allen keys. A lot of times I also use this set of Allen key for the main service when it comes to the outdoor meter bases and stuff like that. It helps with the turning of the wrist. A lot of times when we go to do the service upgrade, it ends up being that sometimes the lug is stuck and you need something a little bit more stronger. I inherited this from one of the crews that I was working with when it came to doing a service upgrade, and it's one of the tools that I normally travel with. Make sure it's in my bag with the material that I need. It's very with the tools that I need. Sorry, very handy. We're going to remove this from here. As I said, I don't need that, and we're going to be removing this. So in a normal situation like this, if I was coming in with my main wires, over here we have the grounding onto the metal casing of the panel. Up here we have our bonding. This is basically the wire that comes from underneath the ground. You'll see it in some of my videos where ground ground where I have my ground plate inside of the ground. Usually when that comes up out of the ground, we come into the panel and we're going to install it here. However, for this type of setup, I'm not going to be using this because once I come from the main panel, I don't need a bonding. It's already bonded through the set of cables that I'm going to be using. So I'm going to be removing this. Also, another thing that I'm going to be removing from this panel is my bonding strap, as I don't need it. So these are again another handy tool to have. Big, gets the job done. So for all those who are wondering, this is the bonding strap that I'm going to be removing. And I'm simply going to tuck this screw back into the panel. So again, as you guys come in, don't forget to like up the live. Helps my channel to go out into the YouTube algorithm faster. Um, so that's what we have here. Again, as you guys come in, also for those who are tuned into today's live stream, who are watching the live stream, I'm going to be going live tonight on the full breakdown of the Canadian Electrical Code and try to break down the international code book, as there's probably not too much of a difference. You can join me tonight, catch the live at 9 p.m. tonight when I go fully in depth into the code book. So again, that was the bonding strap that I removed. I don't need that bonding strap. So I'm going to take this out of here. Um, so we've completed the grounding. We've went over the bonding, how it goes. So my new cable that I'm going to be feeding into this panel, I'm going to be grounding off this panel. I'm going to use my ground wire and I'm going to ground it here. I'm not going to be going on to here. As I said, this panel is going to be already bonded through the main panel. So it doesn't require you to actually bond it again. Actually, it's in the code book. For those who wants to double check, you can. And again, these are my white cables that I'm going to be using. Since I've already tied in my grounds, next thing you do is you simply go and you tie in your neutral cables. So again, hello and welcome back to the channel. You guys are tuned into Fabian Electrical Services. I'd like to thank you guys all for tuning into today's quick live stream. Before I go live tonight, again, I'm going to be going live, so you can catch me live tonight at 9 p.m. So always remember, when right now I'm using my pliers to strip the cable. There's a certain way that we use that in order to not damage the end of the cable. Another tool that I like to use is, you can see it's insulated. Helps with when the panel is live. If we have to do a quick job, you can touch around here. You can touch around the breaker. Again, this is not live, but this is another great tool that I like to have on me when it comes to cutting in my cable when I have to install a quick service call. It helps with the knowing that it is insulated. You always try to keep your maintain that you're working live, even if you're not working live. It's a code, it's a rule that we've always followed throughout our years. So right now I'm treating this panel as though it's live, but it's not live. Always try to do a little bit of what you need. You simply go with the momentum. Make sure that this wire is not broken, and you're good to go to install it. So again, these cables are all not going to be on an arc fault. That's why I'm landing these cables right now. Eventually, I'm going to be transferring from one end to the other, from the other panel to over to this panel. So I will have some arc faults here. So hello and welcome back to the channel. I'd like to thank you guys all for tuning in to tonight's live stream. Again, as you guys come in, don't forget to like up the live stream, please and thank you. And also, we will be going through some videos tonight. I am live tonight. Um, if you guys have any questions, you can drop your comment in the comment sections as I continue with my sub panel grounding and bonding. Uh, Again, as you can, please and thank you. Don't forget to like up the live stream. Very important. And we have in today's quick live is I'm going to be installing a 100 amp sub panel. Reason being is the main panel is going to be filled up. So, and I'm going to have a lot of arc faults inside of the main panel. So I'm going to transfer a lot of my circuits, my smaller circuits into this sub panel. It's a 100 amp Siemens panel. Uh, I'm going to also be removing this stuff here from the panel. So at a later time, you'll see a full video of the full installation of the panel. These are my ground wires that I have installed. As you can see, I have them neatly separated. Whatever wires I have on this side, I'm going to go on to this side with my main wires, ground wires. So this is the ground bar that I'm going to be using right here. These are going to all pick up the grounding wires. Same thing on this side here. These are all going to pick up the grounding wires on this side. Um, this here is going to be the main compartment where I'm going to be using. This is going to be my breaker that I'm going to be using to power up this eventually. And we're going to have a couple of breakers. Again, these are all 20 amps, so I always try to maintain that one side is going to be loaded properly. So I have 20 amps. I'm going to mix and match a couple 15s, couple 15s and 20s. If I have to do any 30 amp two pole, I'm going to land them on this side evenly, one on each side. Also, again, don't forget, I'm going live later on tonight, 9 p.m. It's going to be about the code. So, again, for all those who are tuning into the live stream today, you can catch me live tonight, 9 p.m., about the Canadian code book. You can post your questions in the comment section if you have any, and we'll go from there. So this is my 15 amp Siemens breaker. Always remember to make sure to use the same breaker as the panel. As you can see, it's a 15 amp Siemens. Okay, and that's the name of the panel. It's a Siemens 100 amp panel. So whatever I have in here that I have to use, they're all going to correspond with the Siemens. As you can see, the label is right here. Everything is here. You know that this is approved. Again, this is bought. You have the stamp here, okay, directly from the store. We also have some other writings here, as you can see. So when it comes to the breakers, they're filled with info, and I'm going to again. This is a 15 amp breaker, and how I'm going to install it. I'm going to simply position that like that, and I'm going to push this down. Always make sure that it's level. So a lot of times when this happens, okay. What I normally do that I find with the Siemens breakers is I loosen it up a little. Okay, and that's normally how I install my breakers. Pav, harmony, Jesus Christ, please be careful around those cables. Yes, it's not live. Like I said, this is a sub panel, not in live. Okay. So again, these wires up here are all going down into here. So this panel, as you can all see, is not live. Um, the main compartment is going to be up here. So again, there's nothing live on this panel. Again, as you guys come in, please don't forget to like up the and thank you. Helps YouTube to push my videos out into the algorithm a lot more. So this is another 15 amp breaker I'm going to be installing. Same thing, Siemens brand. Okay, and then you have my grounding here that I'm going to be positioning properly when it comes to grounding off the cables. As you can see, I'm all positioning my wires in the same location. Again, thank you for the support. Here's for good luck. PRVT Haruma. Again, thank you for the donation towards the channel. And again, also don't forget to, you can catch my live later on in the evening tonight around 9 o'clock, where I go fully in depth into the code and why the code book is used and why it exists. It simply exists for reasons like this. Ground wire. I'm going to be going on to the grounding bar. Okay. So watch the way I position my ground. I shape it when it comes to the panel. I try to stay away from this compartment here. That's going to be livened up eventually. So what I mostly do is I try to get my grounding wires all the way over, tuck the way over into the corner. So also with the holes that you're going to be seeing by code, I have to make sure that these holes are covered up. This is an old panel, not an old panel, but this was used for temporary power. With the panel itself, it's all intact. So for that reason, I'm going to be using it inside of the home instead of throwing it out into the pile of garbage. There's nothing wrong with it. It's just used for temporary. Um, Also, when it comes to the panel, so again, this is my face plate here that's going to go onto there once I remove these wires from here. So it looks like that is reamed out. So I'm going to somehow have to get this off or take this up in order to remove, to remove this from here. Um, so these are my Allen keys that I normally travel with. Never forget your Allen keys. There's many sets that I have here. I also have this set of Allen keys that I use for the bigger stuff. Comes in handy. Um, as you can see, I tried with these Allen keys the first time, didn't work. So I simply went to the other set of Allen keys. A lot of times I also use this setup Allen key for the main service when it comes to the outdoor meter bases and stuff like that. It helps with the turning of the wrist. A lot of times when we go to do the service upgrade, it ends up being that sometimes the lug is stuck and so hello and welcome back, all my viewers and subscribers. I'd like to thank you guys all for tuning in to tonight's live stream. And my name is Fabian. Again, as you guys come in, kindly don't forget to tap up the like. And as we're going to be continuing with the Masterclass series tonight. Welcome back to the channel. This is episode 4 of the Grounding and Bounding Masterclass series. Today we're covering grounding and bounding under OESC 2024, the rules the electrician gets wrong most often, and the exact reasons inspection fails. By the end of this video, you will understand grounding versus bounding. They are not the same. GEC sizing, ground rod versus ground plates, sub panels neutral isolation, grounding versus bounding. Let's clear this up right away. Grounding connects the electrical system to the earth. Its purpose is voltage stabilization and lightning dissipation. That's it. Electricians, this is where most people get grounding and bounding wrong. In this masterclass, I'll break down real code rules, grounding electrode conductors, and why bounding does not work the way you think. If you work on panels, services, or sub-panels, you need to see this. Full breakdown on my channel. Link in the bio. Your ground and neutral must only meet at the main disconnect. Remove the bounding screw. Add a bounding jumper to the metal case. Many might ask, what is the purpose of bounding? Bounding connects all metal parts together, so they are at the same electrical potential. Bounding is not what clears faults and trips breakers. If you mix these up, inspectors will catch it immediately. Under OESC reference Rule 10-200 and also 10-206. Section 2. Why the GEC does not trip breakers. The grounding electrode conductor is not a fault clearing conductor. The GEC stabilizes your system voltage. It also reduces your lightning energy. It also provides an earth reference. Fault current flows on the equipment. Bounding conductors, not the GEC. This is one of the most misunderstood concepts in the trade. And you can also refer to OESC reference 10-106. Section 3, GEC sizing. The GEC size is determined by the service conductor size, not the breaker size. So always remember this. Typical example is 100 amp service, number 8 copper. 200 amp service, number 6 copper. 400 amp service, number 4 copper. Never guess this. Inspectors expect you to know the table. Reference OESC Rule 10-210, Table 16. Section 4, ground rod versus ground plate.
A ground rod must be at least 3 meters, or which is equivalent to 10 feet, and be driven full length into the undisturbed soil. Use a listed direct burial clamp. If soil conditions prevent proper rod installation, a ground plate is allowed. Plates must meet minimum surface area, be buried at required depth, be connected with a continuous GC, and again you can reference OESC rules 10700 to 10702.
Your neutrals must stay isolated. Your ground and neutral must only meet at the main disconnect. Remove the bounding screw. Add a bounding jumper to the metal case. Rule 10-806 and 10-808, bounding and distribution equipment. And also, don't forget to subscribe to the channel or become a member of the channel. Your neutrals must stay isolated. Your ground and neutral must only meet at the main disconnect. Remove the bounding screw. Add a bounding jumper to the metal case. Rule 10-806 and 10-808, bounding and distribution equipment. And also, don't forget to subscribe to the channel or become a member of the channel.
Section 5, sub-panel grounding and neutral isolation. In sub-panels, neutral must be isolated. Ground bar bounds to the enclosure. Bounding screw must be removed.
The ground rod needs to be
neutral and ground only bound at the main service disconnect. So always remember that. Bounding them again downstream creates a dangerous parallel path. And you can refer to OESC reference rule 10-806, 10-808. And this is section 6, common inspection failures. The most common failures inspectors see: bounding screw left in the sub-panel, undersized GC, no bounding bushing at metal raceway.
I don't need a bounding. It's already bounded through the set of cables that I'm going to be using. So I'm going to be removing this. Also, another thing that I'm going to be removing from this panel is my breaker sizing. Do you go by rule of thumb or do you calculate every load? In this premiere, I'll show you the real load and when inspectors will call you.
Common inspection failures. The most common failures inspectors see: bounding screw left in the sub-panel, undersized GC, also having no bounding bushings on metal raceways, incorrect ground rod installation, mixing neutral and grounding conductors. That's episode 4 of the Grounding and Bounding Masterclass. If this helped you, like the video, drop a comment with where you're watching from, and subscribe for the next episode. Stay safe.
Welcome back to Fabian Electrical Services Inc. Today we're starting episode 1 of the Grounding and Bounding series, and we're breaking down the most important part of any electrical service, the main bounding point. If you understand the
the main bonding point. Grounding and bonding finally make sense. If you get it wrong, you create short hazards, parallel path, and code violations. Today I'm going to show you exactly where it goes, why it exists, and how the OESC 2024 wants it done. What is the main bonding point? Let's start simple. The main bonding point, also called the MBP or the MBJ, is where the neutral is bonded to the metal enclosure of the service. This is the only place where neutral and ground connects together. Everywhere else in the system, sub-panels, disconnects, downstreams, AC panel, pool panels, the neutral must stay isolated. Without a correct main bonding point, faults won't clear, breakers trip slowly, stray voltage appears on metal, short risks increase, code violation piles up. This one point controls the whole grounding and bonding system. Under OESC 2024, the main bonding point must be located at the first means of disconnect, not the meter, not the sub-panel, the first switch or breaker that can shut off all power to the building. In homes, it's the main panel. In some industrial commercial setups, it's the disconnect before the panel. Inside that point, you will see one of these: a bonding screw green, a bonding strap, a factory installed jumper. This device ties the neutral bus to the metal enclosure, creating the low impedance path needed for faults to return instantly. So in this situation, my main bonding point will be at my main disconnect that is located at the side of the home where it was bounded from that point on. The bonding screw is one of the most misunderstood pieces of hardware in the trade. Here's how it works. You have a neutral bar floating inside the panel. The bonding screw threads into the enclosure and touches the neutral bar, connecting metal to neutral. This creates a return path for fault current, a low resistance path to trip breakers, one single grounding reference point. If you miss the bonding screw in a service panel, you get stray voltage, tingles on appliances, breakers not tripping fast, metal boxes reading hot under faults. Now let's talk about grounding. The grounding electrode conductor, the GEC, connects your service to the earth. But here's the most important rule. The GEC must land at the main bonding point, not in a sub panel, not on a random ground bar. This means your ground plate wire or ground rod lands on the neutral bar in the service or the grounding lug inside the disconnect. This becomes your zero reference, stabilizing voltage and maintaining surge, lightning, and faults. Once you leave the main bonding point, everything changes. Downstream panels must have isolated neutral bars, have bonded ground bars, have 4-wire feeders, hot/neutral/ground, have no bonding screw in the neutral bar. If you bound neutral and ground downstream, you create parallel path. You energize metal parts. You backfeed current on conduit. You violate code. You risk shot every time someone touches metal. This is the number one mistake apprentices make. Only one bonding point at the service. If you ever see two bonding screws, neutral and ground, tied together in a sub-panel, neutral bar touching the case, GEC landed in the sub-panel, that's wrong, that's dangerous. Proper grounding and bonding is what keeps the entire system safe and predictable. And when it's right, it makes troubleshooting a million times easier. This is episode 1 of our grounding and bonding series. Next episode, we're covering grounding electrode conductors, size, location, and OESC rules. If this helped you, hit subscribe, drop a comment, and stay grounded safely.
I'm going to take my bonding strap, which is here. I'm going to remove that from my panel and tuck it to the side. I don't need that either. Again, also when it comes to your breaker, this is a Siemens panel. sorry, this is a 100 amp Siemens panel. This is the main compartment where it's going to be landed. After once it's landed, I'm simply going to be using this cover here to place it. And the marking that we're always looking for to make sure that it is labeled accordingly. There's another marking that we have to look for when it comes to the safety installing the panel, and it's called this right here. Once the inspector comes, he's going to be looking for this symbol right here. Symbol clarifies that I can use this panel. Simply, when, for instance, when I was doing the my first panel here, I missed it. The panel cover didn't have the information on here. I'm not sure. Randomly happens, and I needed to bring the panel cover back to the supplier in order to have this sticker so I can have the inspection pass. So very important. This is a key part of your installation. Key part of your inspection is to always make sure that this here is what you're looking for when it comes to the installation of a new panel. If you don't have this here, if this marking is not on the panel cover here, comes to the
Good night, post
I just had a call.
1552. Again,
So when you want to be
thank you
looking
for
for
tuning
your
into tonight's live
breakers
stream.
and what you need
Also,
to
you
use,
can leave a comment
you're
in the
going
comment
to
section.
be this is what you're
Telling
going
me
to
where
looking
you're
for.
tuned in from,
It
if you're
has the
electrician,
information here.
homeowner,
Very important
or
to make sure that when it comes to
DIY.
the code, you have this information on the cover of the panel. It's going to give you the list of names of breakers that you're allowed to use inside of the panel, which a lot of us are not aware of.
Chanel. That's your name, Chanel? Sinead? Or that's where you're from?
So also, like I said, for all those who are tuned in into today's live stream, I will be going live tonight. So please, you guys can come out and join the live tonight. It's going to be fully in depth into the code book. You're probably also going to see a replay
Again,
of
I'd like
this
to thank you
video
guys all for
explaining
tuning into
what's
tonight's live
going on
stream.
here with the grounding and bounding. Also, you're going to see me explaining one more time past all miss the live
When
stream.
you say
As you
split
can
phase,
hear,
what are you referring to?
sometimes what happens is there's a Eaton breaker. It looks the same. Again, this is the Eaton breaker, and a lot of times what happens is sometimes
Bless up
you'll end up
yourself, the real
seeing
Gaza
these
uncle.
different types
Again,
of
thank you
breakers
for tuning
inside of
into
the panel,
tonight's live stream.
and it does
Post
look similar.
negative vacuum
As you can see,
pressure
it
on the
does look the
neutral.
same.
Negative,
Two
yes.
different names
Sometimes
that we have here.
when you do
For
turn
this
the
reason, this will fit into the panel.
when you do turn your
However, when it
vacuum
comes to
on
your
and you're
final
using it
inspection,
at
you cannot have
on a
a
15 amp
Eaton
circuit,
breaker inside of a
it
Siemens
does
breaker.
send back
A Eaton breaker inside
negative
of a
reading,
Eaton
and
Siemens panel,
it does strip the
or you
breaker.
cannot
Is
have
that what
a
you're referring to?
Siemens breaker instead of a Eaton panel, vice versa. The inspector is not going to pass the job. And also, as you can see, previously explained, these are the names of the breakers that we can use inside of the panel. So anything that correspond with these names here, Siemens, we can use inside of the Siemens panel. The way how I position this is As you can see, this is where the blade is going to go onto the panel. This is where it's going to go onto the back of the panel. I kind of do it like that and push it down. So as you can see, it's lifted, and I'm going to install my basically
Oh,
so
you're
what I've got
referring to the
here is
transformer
this is my
where
20
you
amp barrier
you
cable.
take your
As
main
you go down
grounding point
when it
from
comes
the
to the barrier
transformer.
cable,
Is
we
that
have
what
to
you're
have
referring
two
to?
hots,
The
one
connection
neutral.
inside of
So
the
these are
transformer
my
where you
two
have your
hots. I'm going
phases
to be tying
A,
on
B,
to a
and
2
C,
pole breaker
and
eventually.
you have your
And again,
zero
had
for the neutral
previously
point
discussed
where
in
you
the
take your
first
grounding off. Is
part of
that
the live
what you're
stream.
referring to?
When it comes to the breakers, always maintain loading your panel properly. When I say loading each side properly, I mean this is a 20 amp, this is a 20 amp, this is a 20 amp. These are 15s. Eventually, I'm going to put a couple 15s here. I'm going to put a couple 20s here. Also, if I have two double pole 40 amps, I'm going to place one on this side, and I'm going to place another double pole 40 on this side. It helps with the balancing of the panel. And when I say balancing of the panel, it helps to balance out each side properly. You don't want to have one side overloaded and the other side off. It's going to eventually give you problems when you start to work the panel. So for that reason, we try to load the panel as properly as we can. It is part of the code. Also, when it comes to this panel, I'm going to have to leave a couple spaces open for future, either this panel or the main compartment. I have to the panel free up for space just in case there is work that's going to
Yes,
happen
that's why
in
you
the
should be
future.
receiving
I
0
cannot load
volts.
this entire panel and load the main panel and don't have uh, nothing to play around with. I'm not going to have the inspection at the final.
Okay, so post, you are referring to the North American split phase system. I'm assuming you're located somewhere in North America where you have your two hot conductors, L1 and L2, one neutral. Neutral is center tap at the transformer. So split phase, the transformer secondary is 240 volts total. The center tap creates 120 volts from L1 to neutral, 120 volts from L2 to neutral, 240 volts from L1 to L2. So yes, it's a split phase. So the neutral is the center tap. It is bonded to the ground at the surface. So yes, it's grounded at the surface only. Neutral is bonded to ground one time. The bond is to establish reference to earth. That's why we call it 0 volts reference. So I hope that's what you're referring to. Again, if you have any more comments, you can drop it in the comment section.
as I'm answering the live tonight. I am live tonight, and I will reply to your comments. Just drop the comments in the comment section, and I will reply to your comments. So again, thank you guys all for tuning into tonight's live stream, and I'm going to be continuing with the live stream.
And when I say balancing of the panel, it helps to balance out each side properly. You don't want to have one side overloaded and the other side off. It's going to eventually give you problems when you start to work the panel.
Okay,
So
so
for that
I'm assuming
reason,
that
you
you
try to
gave me the high
load
five that answer your question.
panel
So
as
I'm
properly
glad that I
as
can help
you
you out with
can.
the
It
comment that
is
you left
part
in
of
the
the
comment
code.
section.
Also,
Again,
when it
thank you for
comes to
tuning into
this
tonight's
panel,
live stream.
you have to leave a couple spaces open for future, either this panel or the main compartment. I have to the panel free up for space just in case there is work that's going to happen in the future. I cannot load this entire panel and load the main panel and don't have uh, nothing to play around with. I'm not going to have the inspection at the final.
So again, as you guys come in, don't forget to like up the live stream. Please and
Also, I
thank
do
you.
not need all of this. This is too excessive, so I'm going to be trimming it down to what I need. And voila, that's basically how you install your grounding. As you can see, I have my ground wires tucked behind. I want to make sure that my ground wires are tucked behind. I don't want them to come in contact with the live compartment once I liven up the panel. So again, this was just a quick live stream for all those who tuned into the live stream. I would like to thank you guys all for tuning in to today's live. And you can catch me live tonight. I'm going live tonight at 9:00 p.m. in the evening. It's going to be a full.
Welcome back to the Grounding and Bounding Masterclass series. Today in episode 4, we're breaking down one of the most confusing parts of OESC. Ground rod versus ground plate, and when you're required to use each one under the OESC 2024. We'll cover code rules, conductor size, depth, connection methods, and the real world difference between the two. A ground rod is simply a vertical grounding electrode. It gives the service a different point to earth, helps stabilize voltage, and reduce lightning impact, but it does not trip breakers. Under the OESC 2024, your ground rod must be at least 10 feet, 3 meters long, half-inch steel or copper clad, driven to the full depth unless rocks stops it. Minimum 600 meters, 2 feet above grade for the conductor clamp. The GEC can be copper, aluminum, or copper clad depending on location exposure. A ground plate replaces the rod when driven. A rod is not practical, such as rocky terrain or bedrock. OESC Rule 10-802A and B, allows a ground plate as an alternative electrode. A complement ground plate must be minimum 0.2 meters square surface area, minimum 6 meters thick, buried at least 6 millimeters below grade, copper or galvanized steel depending on corrosion. The plates create surface area with earth that makes up for not being able to drive a rod. In normal soil, a 10-foot rod is faster, cheaper, and code approved. But in certain locations, northern Canada, rock, ledge, a rod is useless because you can't get proper contact. Use a ground rod when soil is soft. You can drive the full length, standard residential or light commercial. Use a ground plate when bedrock stops rod penetration, rod depth is impossible. ESCR inspectors prefer surface area contact. You need an alternative electrode. Under OESC 2024 Rule 10-806, your grounding electrode conductor size depends on service conductor size. Example, 100 amp service, number 8, copper. 200 amp service, number 6, copper. 400 amp service, number 4, copper. Aluminum must be upsized and cannot be used when exposed to physical damage. How GC bonds to rod or plate. Connections must be made with a listed approved clamp, weather resistant, accessible unless buried, copper to copper preferred. Never put the GC under a lug not ready for grounding. Never use a set screw lug meant for feeders. So remember this: ground rod, vertical electrode, 10 feet long. Use where soil allows full depth. Ground plate alternative electrode, 0.2 meters square, minimum surface area. Use where driven a rod is not possible. And your GC only creates the reference to earth. Bonding is what clears the fault. So as you can see, these are the rules that align with today's video. And it says here again, perfect for rocky soil. And as you can see here, it says grounding electrode conductor to ground rod, ground plate electrode installation. These are the diagrams, main service bonding jumper. As you can see, there's a perfect diagram of what I've been talking about. So when it comes to ground rod versus ground plates, what do I prefer? I prefer ground plates. Reason being is with the ground rod, you have to drive it into the ground. And again, when it comes to underground, you do not know what's buried underneath the ground. For that reason, you possibly have to have the ground scanned. You don't want to drive a ground rod into the floor and not knowing what is underneath the surface. You can hit conduit, existing wire, whatever may be, that was buried before underneath the ground. So it becomes very dangerous when it comes to ground rod. So for that reason, ground plates I prefer. You can dig. You have to dig for the ground plate to bury your ground plate, opposed to ground rods. You drive it into the ground using hammer. I've seen some people use tools to drive it into the ground. So this is the reason why I like to use ground plates, and I'm sure many other electricians approve of ground plates also. But again, it's not up to us, it's up to the code book. It's up to what is required by code wherever you are working in that situation. So for all those who are tuned in into today's live stream, don't forget to give it a thumbs up. Don't forget to smash that like button. Don't forget to make sure your notification is turned to all. That way you can receive my regular videos, my live streams, and my shorts that I post. You can also share the video to someone else. And I will catch you guys on the next live stream.
So again, hello and welcome back to the channel. I'd like to thank you guys all for tuning in tonight's live stream. You're tuned into Fabian Electrical Services, and I'm Fabian. Again, as you guys come in, don't forget to give it a thumbs up. And I'm going to be continuing my sub-panel grounding and bonding masterclass series tonight. For all those who missed the start of the live stream, you can catch it on the replay. You can also leave a comment in the comment section on the replay. You can also leave a comment in the comment section tonight if you have any questions, and I will respond to them live tonight.
Welcome back to the Masterclass series. Today we're going into the heart of the 400 amp service. I will show you line side and load side of a 400 amp disconnect. And most importantly, how grounding and bounding ties into everything under the OESC 2024. On the line side of the 400 amp disconnect, this is where all utility conductors enter under OESC 2024. Rule 6-300. The service conductors must be sized accordingly and physically protected from damage. You'll normally see a 350/500 MCM aluminum, depending on distance. Separate neutral conductors, full-size bonding conductors. Everything on the line side is unprotected, so treat it like it's live, even when it's not touching these. Wrong is not a second chance situation. On the load side, once you exit the disconnect, your conductors are now protected by the rating of the disconnect. In this case, 400 amps. This is where you feed the 400 amp main panel, or split the service into two 200 amp panels using a splitter. Under OESC Rule 6-112, your disconnect must be grouped, readily accessible, and serviceable. Bonding is not grounding. Bonding is connecting all metal parts together so a fault clears quickly. This falls under OESC Rule 10-606 and 10-6112. Bonding the metal raceways, bond the disconnect enclosure, bond the neutral at one point only, the main bonding point. Never rebound in a subpanel. When the bonding screw is in the round place, your panel becomes energized. This is how houses burn down. Under OESC Rule 10-700 to 10-708, the GEC connects the service to the earth stabilizing, not the tripping breakers. GEC does three things: stabilize voltage, reduce lightning impact, connects the electrical system to earth as a reference point. It does not clear faults. Bonding clears faults. Grounding stabilize. Also, quick reminder, as you guys enter, don't forget to smash that like button. It helps with the channel. You can also subscribe to the channel. You can also become a member of the channel. You can also share the video. On a 400 amp service, your GEC can land inside the 400 amp disconnect, on the neutral bus, at the main bonding point. Never land the GEC in your subpanel.
The GEC is the conductor that connects your service to the earth. Using grounding electrodes, it does not trip breakers. It stabilizes voltage, reduces lightning impact, and connects your service to the earth reference point. Ground rods 5/8 in diameter are usually 10 feet long, must be fully buried, copper or listed steel. Ground plate minimum 24 times 24, buried 600 mils or 24 inches deep. Must be labeled direct burial. If soil is rocky or rod depth cannot be achieved, grounding plate is used.
If you want more in this series, drop a comment. Episode 3 is ground rod versus ground plate with full OESC breakdown. Stay safe, stay grounded. You can also subscribe to the channel, become a member of the channel, like and share the video, and I'll catch you guys on the next video.
Welcome back to the channel. This is episode 4 of the Grounding and Bounding Masterclass series. Today we're breaking down grounding versus bounding, the code rules under OESC 2024, and the extract mistakes that cause inspection failures. If you wire panels, sub-panels, or service equipment in Canada, this episode is a must. First, let's clear this up because a lot of people mix these up. Grounding connects the electrical system to the earth. Its job is to stabilize voltage, reduce lightning and surge impact, provide a reference point to ground. Bonding connects metal parts together so they are at the same electrical potential. Bonding is what actually clears faults and trip breakers. They are not the same, and the code treats them differently. OESC reference Rule 10-200/10-204, purpose of grounding and bounding. This is a big misconception. The grounding electrode conductor, the GEC, does not trip breakers. It is not a fault clearing path. The breaker trips through the equipment bonding conductor, not the ground rod. The GEC role is voltage stabilization, surge dissipation, surge dissipation, earth reference, that's it. OESC reference Rule 10-106, 10-210. GEC sizing is not guesswork. It's straight from the code. Under OESC Table 16, 100 amp service, number 8 copper. 200 amp service, number 6 copper. 400 amp service, number 2 copper. If you undersize this conductor, inspector will fail it. Aluminum conductors must be upsized and protected from corrosion. OESC reference Rule 10-210 plus Table 16. And for all those who are tuning into today's video, please don't forget to give it a thumbs up, share, and subscribe to the channel. And you can also become a member of the channel. Let's talk electrodes. A ground rod must be minimum 8 feet, 2.4 meters, driven full length into the earth, tested to 25 ohms or less, or you add a second rod. A ground plate is used when rods aren't practical. It must be minimum surface area per code, buried at proper depth. Direct earth contact. You don't choose based on preference. You choose based on site conditions. OESC reference Rule 10-700 slash 10-702. Main panel versus sub-panel bonding. This is where most people fail inspection, at the main service disconnect. Neutral and ground are bonded. At a sub-panel, neutral must be isolated. Ground bar bonded to the full enclosure. Leaving the bonding screw in a sub-panel creates parallel path, short hazards, and stray current on metal. OESC reference Rule 10-806, 10-808. Here are the mistakes inspectors see all the time. Neutral bonded in a sub-panel. Undersized GEC. Ground rods not driven full depth. Improper ground clamp. Mixing copper and aluminum without anti-oxide. No bonding bushings on surface race. Fix these and you pass most inspection. That's episode 4 of the Grounding and Bonding Masterclass series. If this helped you, like the video, comment where you're watching from, subscribe for the next episode. Stay safe and stay grounded. Welcome back to the Grounding and Bonding Masterclass series. This is episode 3, and today we're breaking down the difference between a ground rod and a ground plate, and when each one is used under the OESC 2024. This is the one area apprentices mix up all the time, and even licensed electricians sometimes install the wrong grounding electrode or size the conductor wrong. By the end of this video, you'll know exactly which one you should be using, how to install it, and the code rule behind it. First, let's clear the biggest confusion of the grounding electrode system. Rod plates, concrete encased, whatever does not trip breakers. It is not a fault clearing path. It is bonded. It is not bonded. Grounding electrodes do 3 things: stabilize voltage, reduce lighting impact, provide an earth reference for the service. That's it. Breakers trip because of bonding, not the earth. Section 2, ground rods. Let's start with the ground rod, probably the most common
electrode people think of. In Canada, OESC 2024, minimum 10-foot rod must be copper clad or stainless steel. Minimum diameter 12.7 millimeters, half inch. Must be driven full length into the earth. Cannot be bent or angled. Must be distributed style. Must be in undisturbed soil. If the rod does not achieve 25 ohm, then OESC allows a second rod, a ground plate, or an acceptable alternative electrode. Number 6, copper minimum for most residential, 100 amps/200 amps. Number 4 or larger for 400 amp service, dependent on service size. OESC 2024 Table 16. Your rod must be tested or paired with another electrode. Now let's talk about the ground plate, the one most people forget about. In Ontario and many parts of Canada, the ground plate is extremely common because our soil is rocky, frozen, or too hard to drive rods. Ground plate requirements, OESC 2024, must be at least 0.2 meters square surface area. Minimum 6 millimeters thick copper or acceptable steel alloy. Buried at least 600 mils, 24 inches underground. Must have direct contact with earth. Must be installed horizontally for maximum contact. Clamp must be accessible. Plates are expensive but very effective where ground rods fail. GC size, same rules based on service size. For 400 amps, typical 4-aught copper minimum must be continuous or irreversible splice. Section 4, rod versus plates. When to use each. So which one do you choose? Use a ground rod when soil is soft. You can achieve full depth. You can get 25 ohms or install 2 rods. Rural or open ground space available. Use a ground plate when soil is rocky. Rod cannot be driven. Space is limited. You want a guaranteed grounding electrode. Cold climates where frost line is deep. In Ontario, we use a ton of ground plates because of soil conditions. Contractors use rods where soil conditions allowed. Here are the OESC 2024 sections for this episode. Rule 10-6700 states, grounding electrodes permitted. Rule 10-702, grounding electrodes installation. Rule 10-806, grounding electrodes conductor sizing. Table 16, minimum copper and aluminum conductor sizes. Rule 10-802, rods and plates characteristics. Rule 10-902, connection to ground rods and plates. Keep these in your code book. You will use them every day in the field. Here are the OESC 2024 sections for this episode. Rule 10-6700 states, grounding electrodes permitted. Rule 10-702, grounding electrodes installation. Rule 10-806, grounding electrodes conductor sizing. Table 16, minimum copper and aluminum conductor sizes. Rule 10-802, rods and plates characteristics. Rule 10-902, connection to ground rods and plates. Keep these in your code book. You will use them every day in the field. So that's your full breakdown of episode 3. Ground rod versus ground plates on the OESC 2024. Understanding the difference helps you choose the right electrode based on soil conditions, code requirements, and also service size. If you followed this masterclass series, episode 4 is coming next. We're going into neutral isolation and how to wire sub-panels correctly. Drop your questions below. I respond to everything. Stay safe, stay grounded.
Good night, Miss Ching. Again, thank you for tuning in to tonight's live stream. So again, I'd like to welcome you guys back to tonight's live stream, sub-panel grounding and bounding masterclass series. Again, I'd like to thank you guys all for tuning in to tonight's live stream. Also, the real guys are Uncle, Miss Chin, and Posh 1552. Welcome to episode 2 of the Grounding and Bounding series. Today we're breaking down the grounding electrode conductors, also known as the GEC. One of the most misunderstood parts of electrical work. After this video, you will know exactly where it goes, how to size it, and how to install rods or plates correctly on the OESC 2024. The GEC is the conductor that connects your service to the earth. Using grounding electrodes, it does not trip breakers. It stabilizes voltage, reduces sliding impact, and connects your service to the earth reference point. Ground rods 5/8 in diameter are usually 10 feet long, must be fully buried, copper or listed steel. Ground plate minimum 24 times 24, buried 600 mils or 24 inches deep. Must be labeled direct burial. If soil is rocky or rod depth cannot be achieved, grounding plate is used. For a 100 amp or 200 amp service, most installs use number 6 copper rod for rods or plates. For 400 amps, many jurisdiction requires number 4. Always check table number 16 in the OESC for the exact sizing. Keep GAC as straight as possible. Protect where exposed. No sharp bends, must be accessible for inspection. Use copper direct burial clamps. Never land GEC on your downstream panel. It only belongs at the first means of disconnect. Bonding clears faults. Grounding stabilizes voltage. 2 different systems, 1 safe installation. That's your full breakdown of grounding electrode conductors on the OESC 2024. If you want episode 3 on neutral isolation next, drop a comment and let me know. Stay safe, stay grounded. In the OESC, the grounding electrode conductor is covered under Rule 10/700, and its job is simple.
It connects service equipment to the earth through an approved electrode. Now under Rule 10-10-106, the code explains why we ground systems. It stabilizes voltage, reduces the effect of lighting, and gives your entire electrical system a reference point to earth. But look at this. The GEC is not used for tripping breakers. That's in line with Rule 10-208, where the main bonding jumper provides the low impedance false path. That's why fault current doesn't go down the GEC. It returns on the bonded neutral. The grounded electrode system is not intended to carry fault current or trip breakers. Its function is simple. It's to stabilize system voltage, reduce lightning damage, and connect electrical system to earth. OESC Rule 10-106 System Grounding. This rule describes why grounding, including the GESC, is required. 10-1006 Electrical systems shall be grounded to limit voltage imposed by lightning or line surges and to provide reference to earth. OESC Rule 10-700 Grounding electrode conductors. This was rewritten in the 2021 and 2024 edition. 10-700 A grounded electrode conductor shall connect the service equipment to the grounding electrode. OESC Rule 10-702 What electrodes are allowed. Ground rods, ground plate, concrete encased electrode, structural steel. OESC Rule 10-208 Main bonding jumper. This is why the electrode does not trip breakers. Fault current through the MBJ, not the GEC. OESC Rule 10-208 and 10-210. The system bonding jumper bonding screw scrap must be installed at the first point of disconnection. Downstream equipment must not bond the neutral again. Neutral bars in sub-panels must be isolated. OESC Rule 10-08 requires the neutral to be bonded at the service disconnect only. This is the main bonding point. After this, every panel must have the neutral floating. OESC Rule 10-700 to 10-702 GEC must connect to the grounding electrode, rod, plate, building, steel, rebar. Must be installed continuously without splices, unless in reversible compression. Size based on service conductor size. According to Rule 10-700, the GEC must run continuously to the electrode. You can't cut, twist, or join it unless it's an irreversible connector. OESC Rule 10-700, 10-704, 10-706. Ground rods must be 5/8 diameter minimum. Ground plates must have 0.2 meters square exposed surface area. Electrodes must be connected together if more than one is used. Rule 10-704 clarifies that ground rods and plates can be used, but they must meet the minimum sizing. A plate needs 0.2 square meters of exposed surface area. OESC Rule 10-106 intent. The JESC does not clear faults. The bonding conductor clear faults. JESC job is stabilizing systems voltage and reducing lightning effects. As per Rule 10-106, the purpose of grounding is not to trip breakers, but clearing happens through the bonding conductor. OESC Rule 10-406 and 10-414 must be low impedance, must be sized according to Table 16, must connect all non-current carrying metal parts. Rule 10-406 reminds us the bonding conductor acts like a fault lane, providing the low impedance path that trips the breaker instantly. OESC Rule 10-208.
So again, hello and welcome back to the channel. I'd like to thank you guys all for tuning into tonight's live stream. Again, this live stream was an hour and 40 minutes. It's going to be available on the replay, and also for all those who missed the previous live stream, you're going to see the previous live stream pop up on the screen. Just click it and it will take you there. Again, I'd like to thank you guys all for tuning in to tonight's live stream. Thank all those who tuned in to the chat and left a comment. Also, for all those who are new here, you can subscribe to the channel, stay up to date to my content, and I will catch you guys on the next live stream.